look, our friends are back. Yay! Hopefully you remember these guys from yesterday. They have a new problem today. So their problem is that they are trying to split some cookies, but they only have, wait for it, 7. They have 7 cookies and they are trying to divide these 7 cookies. So they want to do 7 cookies divided by 3 kids. Now remember, when you divide, you have to divide things equally. Can we do this? Yes or no? Pause this video, talk with someone around you. Is it possible to divide these cookies evenly? Okay, hopefully you had a good conversation with someone around you. Now I'm thinking, if I start off doing this, then I know that each of them could have at least 2 cookies. Now, there's going to be 1 cookie left over. So, what are we going to do with this cookie? Well, I'm going to talk to you today about something called remainders. Have you guys ever heard of a remainder? So, sometimes in division, you can't always divide things equally. And so whatever you have left over that can't be divided equally is called your remainder. Now, with different problems, we have to decide logically to do different things with the remainder. For example, in this case, what would you do with this cookie between these 3 people? Hopefully, you said that you would divide the cookie into 3 pieces. So if I physically can't break this wooden block, but if I did, I would break it into 3 pieces. She would get 1/3, she would get 1/3, and he would get 1/3. So each kid would get 2 cookies plus 1/3 of a cookie. Now, that's the first option of things we can do with remainders. We can divide them. So here's another example. Oh, look, it's cookies again. Carly and her sister have 7 cookies to split. If they split them evenly, how many cookies would each of them get? Well, Carly and her sister, that's 2 people. So 7 divided by 2. Well, I know Carly could get 3 and her sister could get 3. That's 6 cookies. That last 7th cookie we would have to split in half. So each sister would get 3.5 cookies. Don't waste a cookie, you guys. Divide the remainder. Now, what do we do in a situation like this? Books are on sale for $7. Peter has $30 in his wallet. How many books can he buy? Okay, so I know that if he has $30 in his wallet and each book costs $7, well, if he buys 1 book, oops, no, that's right, I'm sorry, $30, $7. If he buys 1 book, he's gonna have $23 left. Can Peter buy another book? Yes, he can. I can subtract 7 again. 23 minus 7, I believe that is 16. Am I right? Am I wrong? I'm really tired. Okay, yeah, I think I'm right. Okay, so now he has $16 left in his wallet. He bought a book here, he bought a book here. Can he buy another book? Yes. 16 minus 7 would be 9. So he has $9. Okay, so far he bought 3 books. He has $9 left. So what is he going to do? Well, he's going to buy another book. If he buys 1 more book, he will have how much money left? $2. So Peter was able to buy 1, 2, 3, 4 books. 4 times 7, I'm going to check my math real quick. 4 times 7 is $28. So if he had $30, that means, okay, good, my math was right. That means he has 2 books left over. So what do I do with this remainder? I do absolutely nothing. I drop it. We can divide a remainder or we can drop a remainder. In this case, we have to drop the remainder because this $2 is not going to get him another book. So the answer, how many books can he buy? It's just 4 books. We don't even have to write it out. We could say with $2 left over, Sorry, that looks like a T. We could say with $2 left over, we don't even have to do that because all it's asking us is how many books he can buy. So he can buy 4 books. We dropped the remainder. Okay, now there's one more thing that we can do with the remainder if we come across a problem like this. There are 32 students in a 4th grade class. Each table in the classroom seats 6 kids. How many tables will be needed? So I'm going to do a little bit of multiplication here. This table seats 6 kids. This seats 6 kids. 6 times 2, it's 12 kids. Okay, let me draw another table. That's 18 kids. That is 24 kids. This table is 30 kids. Okay, so here's my tables. There are 6 kids at each table. So how many tables will be needed? So far, we need at least 5 tables, right? We know at 5 tables, we can sit 6 times 5. We can sit 30 kids. So should the last 32 kids, I don't know, should we just make them sit on the ground? Should we kick them out of 4th grade? No, that wouldn't be very fun. We have got to get another table. And even though we only need a spot for 2 more kids, we still have to get the whole table. We can't just buy half a table or a fourth of a table. We're gonna have to buy the whole table. Who knows, maybe some of these kids will wanna spread out a little bit. In this case, what's our answer? How many tables will be needed? Was it 5? No, we needed 6 tables. What did we just do? We added 1 to our quotient. So the last thing we can do with remainders is we can add 1 more. Don't make kids sit on the floor. Okay, hopefully you guys feel a little more comfortable with the idea of remainders. Remainders are such a real life thing that you are going to see all the time. Things don't always come out evenly or equally. So the best thing that we can do as mathematicians is think about the context of our problems and logically what makes the most sense to do with that remainder. Is it like a cookie? Can we split it and divide it? Is it like money? We can't just use only a little bit of money to get the whole book. Or maybe we don't want to leave a kid sitting on the floor. So either way, we have to use our logic to think about the situation and decide what to do with that remainder. You are going to be practicing this today and making some decisions on what to do with remainders. So good luck and use this chart if you need it. Bye, 4th grade.